Now, anytime you have quantities which are equal, like in this case we have the units conversion factor 12 inches equals 1 foot, we will use the very simple basic math fact that anytime two things are equal, we can form a fraction like 12 inches over 1 foot. And as long as the two quantities are known to be equal, then the fraction which is formed by those two quantities must be equal to 1. So the fraction 12 inches over 1 foot is equal to 1. But likewise, the fraction 1 foot over 12 inches is also equal to 1. And that would be true for any of these conversion factors. Once again, let's take something like 2.54 centimeters. Now, 2.54 centimeters is equal to 1 inch. So, the fraction which is formed, 2.54 centimeters over 1 inch, must be equal to 1. And likewise, 1 inch over 2.54 centimeters expressed as a fraction must be equal to 1. This would be true for any units conversion whatsoever. Now let's recall another very important rule of math, and that is anytime you multiply a number by 1, it doesn't change that number. So if you take 4 inches and you multiply that by 1, you are going to get 4 inches. Okay? Multiplying by 1 doesn't change anything. It leaves it exactly as it is. But in our next example, we will show you how to use this very important simple rule of math to convert inches to any of those other measurements that we talked about earlier. Now, if you recall, when we set up a conversion factor, 2.54 centimeters equals 1 inch, and we wrote that as a fraction, 2.54 centimeters over 1 inch, we remember that that's equal to 1. Likewise, 1 inch over 2.54 centimeters is equal to 1. What we're simply going to do now is to go over here to our problem about the 4 inches, and we're going to pick one of those two conversion factors to multiply the 4 inches by, and we'll do that in a very special way. We will do that in such a way that when we multiply by this fraction, which is equal to 1, we will plan it so that we will put the inches on the bottom. Because we want those inches to go away, we want to keep the answer in centimeters. So if we look at our conversion factor, 2.54 centimeters equals 1 inch, we will set it up so that we have 1 inch on the bottom and the 2.54 centimeters on the top. The structures are set up so that the inches are going to be on the top here and on the bottom here. We always put our conversion factor in such a way that we cancel out the unit that we don't want. Canceling out means it'll be on the top in our original fraction, but it'll be on the bottom in our conversion factor. What that's going to force us to do then is to notice that our answer, when you multiply fractions together, you simply multiply top times top and bottom times bottom. So you're going to multiply 4 times 2.54 in order to get the answer that we want. And so, using my iPhone for a calculator, we can simply take 4, multiply that times 2.54, and we will get our answer to be 10.16. So let's go ahead and write that down, that we're going to have 10.16. And now notice in the units, the inches have canceled. The only unit that is left is our centimeters, and so we can say then that 4 inches has been converted successfully to 10.16 centimeters. Now I know what you're going to say. Someone will say, well, that sure seems like an awful lot of work just to convert 4 inches into centimeters, because since centimeters is a smaller unit, of course we multiply 4 times 2.54. That's quick and dirty, and we don't need any such system as this. The problem that we get into many times, though, is that the units that we're called upon to convert are not so easy. We're not familiar with them. We don't know how many Gauss it takes to make a Tesla. Consequently, what we're going to do in our next section here is to talk about making conversions in non-standard units. Okay, so you've heard of the English system, you've heard of the metric system, and now I'm going to tell you about the Rigsby system, because what we've done here is invent a system of measurements that no one has ever heard of before, and we're going to practice making conversions within these. This way you will learn to trust the method and not just necessarily try to remember the rules of multiplying and dividing the way that they've often taught it in school. Now for our first example, we're going to convert 545 Zorks into Zirkles. Okay, so we say, gee, I have no idea what these units are. I don't know how big they are. I don't even know what they represent. I really don't care. Here's what we're going to do. We're going to set up the problem this way. We're going to set up the 445 Zorks. There's the problem that we're starting with, and we will always express this as a fraction over 1. What we want to do now is to see if we can go to our list of conversion factors and see if there is a relationship between Zorks and Zirkles. And as we look down through the chart, we notice there is, right here at the second one, that we have 1 Zirkle is equal to 3 Zorks. Notice that we want to end in Zirkles, and therefore we've got to get rid of Zorks. So what we will do is to set the Zorks here. We'll put it on the bottom of the fraction because we want it to go away. We want it to cancel out. And so we're going to put the 3 Zorks on the bottom. We're going to form our units conversion fraction because remember, since 1 Zirkle is equal to 3 Zorks, then we could have made that into 2 fractions. We could either have the Zirkles over Zorks or the Zorks over Zirkles. In this case, we want to put it this way because we want these Zorks to cancel out. We want them to go away. And so 3 Zorks is equal to 1 Zirkle. Notice that Zorks cancel because they're on the top and on the bottom. If you divide those out, they turn out to be 1. They go away. Notice that then our answer is going to come out in Zirkles. And notice then, since we have the 545 on the top and the 3 on the bottom, this tells us what we're going to do. We're going to end up dividing those numbers. So if we simply pick up our calculator, we'll do that calculate. Now, in this case, it's pretty easy. We could simply take the 545 divided by 3, but oftentimes in these units conversions, we have numbers in these other positions as well. So typically what I will do here is to do what I call zigzag multiplication. We will start out by keying in the 545. We will divide by the number that's on the bottom, multiply by the next number that's on the top, divide by the next number that's on the bottom, and zigzag our way all the way across. So in this case, we'll take our 545, we'll divide it by 1, we'll multiply it by 1, we'll divide it by 3, and when we hit equal, we will get our answer. Our answer is 181.66666 repeating, and of course this is going to come out in Zirkles. So let's take a second and write that down. And so we will have 181.66666 repeating in Zirkles. Notice then that our instructions will always be to round these to the nearest tenth. So we're interested in tenths place, and the way, of course, that we will evaluate that is to look at the next digit, look at the hundredths place digit, and if that is 5 or more, we will round up. We will add 1 in the tenths place. So we will round this at 181.7, and of course then our answers are in Zirkles. And so what we've done is made our first units conversion in non-standard units.